Section 12.3, just to follow up, in last section I did a vector projection, namely I did a scalar projection of a vector onto a different vector and vector projection. If you remember, my example was A was 2, -3, 1, B was 1, 6, -2. Remember we said scalar projection of vector onto a different vector is just the length of the vector. So what we need in order to make sense out of the length, because length cannot be negative, so we need absolute values. So in that example, I forgot the absolute value. So this should read what? 18 over square root of 41. But the question is, when I come up with negative number for a scalar projection, geometrically, what does that mean? Well, it doesn't mean we made a mistake. It just I forgot the absolute value bars around my final answer. Now I'm going to tell you what the geometric interpretation of this is. Remember, I came up with -18 over square root of 41, correct? So if the scalar projection is positive, so that means theta is acute. That means it's an angle between what? 0 and 90. If it is theta is 0, then what? 90 degrees, then they're perpendicular, correct? If the scalar projection is negative, that means what? You have a obtuse angle, which means theta is somewhere between 90 and what? 180, because remember, theta goes between 90 degrees and 180 degrees. In our case, the scalar projection of A onto B came up negative, so that just tells you the theta, the angle between the vectors, happens to be an obtuse vector. And if you would graph this, notice this is vector A, correct? And this would be vector B. Can you see the angle between A and B exceeds 90, but it's less than 180. So to make sense out of this, because we are kind of claiming this is the length of the shadow, so don't forget what? To put this in absolute value bar around -18 around the bar. So the final answer would be 18 over square root of what? 41. Thank you.